Good morning, student. Today we are going to discuss some example related to the function. So first of all, discuss once again recall the definition of function. Function, that means a relation from f from A to set B is said to be a function if every element of set A has one and only one image in set B. So once again, here function is denoted by symbol small f. Here two set we can consider, set A and set B. Now every element of set A has one and only one image in set B is called the function. So we can take one example. Suppose in order pair, here 1, 2, 3, 4, 5, 7 set O. So here in position of set A, only one and only one image in set B. So that's why we can say that this relation is called the function. Here no any element repeat in set A. Clear? Now using by this definition, discuss some more example. So in exercise 2.3, question number 3. A function f is defined by, exercise 2.3, question number 3. Function f is defined by f of x is equal to 2x minus 5. Write down the value of our first question. Write down the value of f of 0. So here equation is present, f of x is equal to 2x minus 5. Now our question is find out f of 0. That means in this equation x in place of written here 0. So we get the value. So 2 into bracket 0 minus 5. 2 into 0, that means 0. 0 minus 5, that means minus 5. Second one, f of 7. So same method here apply, x in place of written here 7. So f of 7, that means 2 into bracket 7 minus 5. 7 to the 14. 14 minus 5, that means 9. Third one, f of minus 3. So again x in place of substitute here minus 3. So 2 into bracket minus 3 minus 5. 2 into minus 3, that means minus 6 minus 5, that means minus 11. So our question is a function f is defined by, like this way, f of x is equal to 2x minus 5. Now our question is find out the value of f of 0, f of 7 and f of minus 3. So here in this equation x in place of substitute 0. So here we get value f of 7, that means x in place of substitute here 7. So here we get value 9 and x in place of minus 3. So again here we get the value minus 11. Now next question, question number 4. The function t, which maps temperature in degree Celsius into temperature of in degree Fahrenheit, is defined by T of C is equal to 9C upon 5 plus 32. Okay. So our question is the function T, which maps temperature in degree Celsius into the temperature of degree Fahrenheit. So the equation is given. Okay. Now our question is find out, first question, find out T of 0. T of 0, that means here position of C in place of substitute in this equation 0. So we get the value of t of 0. So 9 into bracket 0 upon 5 plus 32. 9 into bracket 0, that means 0. 0 by 5 means 0. 0 plus 32, that means 32. Second one, t of 28. So again, in this equation, substitute c in place of 28. So 9 into bracket 28 divided by 5 plus 32. Now simplify this term. So 28 into 9. So 9 8 is 72. 9 2 is 18. 18 plus 7, that means 25. So here 2 5 2 plus, here we can take LCM. So 32 into 5, that means 32 into 5, that means 160 upon 5. Now add both these numbers. So plus 160, that means 2. 412. So 412 divided by 5. So this one is our answer. Next question. T into bracket minus 10. Third condition. So again, here C in place of written here minus 10. So 9 into bracket minus 10 divided by 5 plus 32. Now here cancel out this term. So 5 2 is 10. So 9 into minus 2, that means minus 18 plus 32. So now 32 minus 18, that means minus 14. So here we get answer minus 14. And for condition, the value of C, which is, our question is find out the value of C, and here condition is present, T of C is equal to 212. Okay. So that means in this equation, here we can substitute the value of T of C in place of 212. So T of C in place of written here 212 is equal to 9C upon 5 plus 32. Now first of all 32 written in opposite side. So therefore 212 minus 32 is equal to 9C upon 5. Now 212 minus 32, that means 180 is equal to 9C upon 5. 920 is 180. So here cancel out this term. Now 5 multiply with 5 multiply with 20. So C is equal to 20 into 5. That means here we get the value of C is equal to 100. Okay, clear? Now next question. Example number 21. Our question is find the domain of the function f of x is equal to x square plus 3x plus 5 divided by x square minus 5x plus 4. So how can we find out? Here equation is present. Our question is find the domain of this function. Range is not find out, find the domain. In above question domain is present and find out the range, but in this question equation is present, f of x is equal to like this equation is present and find out domain. So how can we find out? So first of all, in denominator term, here equation is present x square minus 5x plus 4. So first we can written here x square minus 5x plus 4. Now factorize of this equation. So is equal to x square. Now factor of 4. So we get minus 5. So 4 1 ja 4. Right? Factor of 4. So here we get consider minus 4 minus 1. So here using by splitting method. So x square minus 4x minus x plus 4. Now in first two term and last two term, which term common? So in first two term x we can take common. So in bracket x minus 4 remaining term, and in last two term we can take common minus 1. So in bracket x plus x minus 4, here change the sign and here written x minus 4. Now after both the same bracket we can return x minus 4 and remaining term we can return in another bracket. So here x minus 4 and x minus 1 factor of this term. Okay, now this term we can equate with 0. So therefore here we get x is equal to 5 and x is equal to 1. Now our question is find out the domain of this equation. So how can we find out? So this function we are talking in real number. Okay, so in denominator term equation, this equation in place of we can written like this x square plus 3x plus 5 upon x square minus 5x plus 4. In place of written like this x minus 4 x minus 1. Now factor of this term we get like this. Okay, now x in place of here substitute 4. So 4 minus 4, that means this denominator term 0, and any term divided by 0, so here we get not defined term, here we get infinite term. So in this situation we cannot substitute the value of 4. Same way here x minus 1, so here x, suppose x in place of substitute 1, so again 1 minus 1, so here we get 0, and any term by 0, that means again here we can we get infinite term. That means here we cannot substitute the value of 4 and here we cannot substitute the value of 1. So our domain is equal to R. All these value we can consider in real number. कोई भी नंबर हम कंसिडर कर सकते हैं रियल नंबर सिवाय सेट ऑफ 1, 4, राइट. 1 और 4 के अलावा हम कोई भी नंबर कंसिडर कर सकते हैं. सो अवर डोमेन इज इक्वल टू R माइनस सेट ऑफ 1, 4. क्लियर? So first of all, in denominator term, here factor of this denominator term, factorize of this denominator term. So here we get two value 1 and 4. So our domain is R minus set of 1, 4. Now one more example. In exercise 2, question number 3, same type of question is asked. Find the domain. Exercise 2, question number 3. Find the domain of the function f of x is equal to x square plus 2x plus 1 upon x square minus 8x plus 12. So once again factorize of this denominator term. So here x square minus 8x plus 12. Now factor of 12 and add this term, so we get a minus 8. So here we can consider minus 6 minus 2. 6 to the 12. So is equal to x square minus 6x minus 2x, right? Plus 12 in first two term and last two term. So in first two term x we can take common, remaining term x minus 6, minus 2 we can take common, remaining term x minus 6. So here x minus 6, x minus 2. So here we get two value, x is equal to 6 and x is equal to 2, equal to 0. So we get two value. Now f of x is equal to, here we can write x square plus 2x plus 1. Now x square minus 8x plus 12. In place of written x minus 6, x minus 2. Now in this equation substitute this value 6. So we get 0 denominator term and denominator term 0. So here infinite form. Suppose x in place of substitute 2. So again 0. So infinite form. So in domain position we can not consider the value of 2 and not consider the value of 6. So our domain is equal to R minus set of 2, 6. Clear? Okay.